What is going on, YouTube? Just helping you out here. And for today's video, I'll be doing Chapter 11, Problem 3 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 11 is all about rolling, torque, and angular momentum. And Problem 3 talks about a car with 4 wheels. And we are asked to find what fraction of the total kinetic energy is due to rotation. And we are also asked to tell why the radius of the wheels is not necessary to solve this problem. So we know that total kinetic energy, so K total, is equal to K translational, so the translational kinetic energy, plus the rotational kinetic energy. And we can further expand that to K total is equal to 1/2 mass of the car V squared plus 1/2 I omega squared, where I is the inertia and omega is the angular velocity of the wheel. And what we need to do is, since we have 4 wheels, we need to multiply this entire quantity by 4. So the fraction of K rotational to K total is going to equal, our rotational is this quantity here, so we can plug that in. So 4 and then 1/2 I omega squared. And that's over the total kinetic energy, which we wrote right here. So we just plug that in. And if you see, we actually have a 1/2 in every single term, so we can cross all those out. And this will be equal to 4 I omega squared over mcv squared plus 4 I omega squared. And the inertia for a uniform disk is 1/2 mr squared. The issue is we have part of this expression, this term and this term is in rotational and this piece is in translational, so we want to try to get it all in translational so we can combine terms and cross things out. So we need to solve this for translational. So we're going to say 4 I omega squared is equal to, and we know that the angular velocity is velocity over a radius. So now we know all those terms in terms of translational values, so we can plug all them in. We have 4, we have our 1/2 mr squared, and then we have V over R, which we can plug into omega, so that's V over R quantity squared. So this is going to equal 2 mr squared times V squared over R squared. And now you can see we're dividing R squared by R squared, so we can cross those out. And that is the reason why you do not need to know the radius of the wheel in order to solve this problem. And when we combine that together, this is going to be 2 mass of the wheel V squared. So now that we have this relationship between the rotational and translational, so here and here, we can sub this value or this term into this for both of those. So let's do that. So 2 mass of the wheel V squared over mass of the car V squared plus 2 mass of the wheel V squared. And you can see that we have a velocity squared in every term, so we can cross those out. And we are left with 2 mass of the wheel over mass of the car plus 2 mass of the wheel. And all of those values we are given in the problem. Mass of the wheel is 10, mass of the car is 1,000. And then when you plug that into your calculator, you should get 0.02. So the fraction of kinetic energy that is rotational is 2%, essentially. So that's it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question about something I did or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.